notes, we're going to reinforce what you learned in 9.1 on analyzing the graph of quadratic functions, which are those of the form y equals ax squared plus bx plus c. You first graphed what's called the parent function. The parent function is when a is a 1 and b and c are both 0. We did that by making a table of values where we made ordered pairs that we were going to graph. We just put 0 in for x and squared it, put 1 in for x and squared it, put 2 in for x and squared it. Same with -1 and -2. And we had 5 ordered pairs that we then graphed. The shape of this was called a parabola, and it was made by plotting 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4, connecting them and putting arrows at the end. And that gave us the parabola in the parent function's graph, y equals x squared. So then what we did is we started messing with that lead coefficient, that a, that number that's in front of the x squared. In blue is again the repeated graph of the parent function. Notice that it opens up like a cup or like a smile. All I did for the second graph in orange is put a negative in front of it. And look at the effect the negative had. It flipped it over and made my smile a frown, made it open down. So when we have a positive in front, it opens up like a smile, and negative opens down like a frown. So then in purple, what I did is made the graph positive again. So notice we're opening up like a smile, or you might think up like a cup, but it got a lot narrower. It stretched that graph out because the y's got bigger faster. When I put the -1/2 in front, again, for this line green, we're opening down like a frown, but instead of stretching it out and making it narrower, the graph got wider. Picture why that would happen. If I made you 3 times your height, you would get a lot taller and thinner and narrower. If I made you a half of your height, picture me pushing down on you, you'd compress and become wider. So there was the parent function in blue. The negative in front flipped it, made it open down like a frown. The +3 made it open up again like a smile, but it stretched it and made it narrower. The negative again caused it to open down like a frown, but it made it wider or compressed it. So let's reiterate what effect that lead coefficient, or that a, has on the graph of the parent function. The lead coefficient, affected 2 things that we saw. It affected whether that parabola opened up like a smile. That was if the a was positive. Or whether the parabola opened down like a frown. That was when that lead coefficient, or that lead number, was negative. The other effect that that lead coefficient had was whether the parabola got narrower than that of the parent function. And that happened when that a got bigger in absolute value, like a 2, a 3, a 4 got stretched to 7 times its height, making it narrower. Or whether the parabola got wider or was compressed. And that was when a was less than 1 in absolute value, like a half or a third. The graph got wider. But now let's take a look and analyze more about that graph. What effect will that last number, or that c, have on the graph? First thing I want to do is black out that b, or remove it, which means b is a 0 in this case. This might be 2x squared plus 5, or x squared minus 1. Let's go back to the graph of the parent function again in blue, that of y equals x squared. Again, it's opening up like a smile, and a negative would cause it to flip or open down like a frown. But we're going to keep that x squared locked in. We're not going to mess or change the lead coefficient. For the graph in orange, all I did was add 2 to the parent function. And for the graph in purple, I subtracted 5. You'll notice that this turning point on the parent function, that yellow dot, moves up 2 for the orange graph where I added 2, and down 5 for the purple graph where I subtracted 5. Those yellow dots are called the vertices or the vertex of each parabola. And so we can see the effect that adding 2 and subtracting 5 did. It slid that vertex up and down the y-axis, which we're going to later be calling the axis of symmetry. So the c in y equals ax squared plus 0x plus c has what effect on the graph of the parent function? And the answer to that is it moves it up or down on the y-axis. So if we did 3x squared plus 4, we would say that the effect is moving the graph up 4.